Integration, page 3. Use the graphical evidence and known area facts to find. And so here, just to show that you understand what an integral is, that an integral is the area under a curve, they're asking you to use like, rectangle formulas and circle formulas to figure out these areas. So first thing we're going to do is draw a picture. This first one, it says to find the area between x equals 1 and x equals 3 of the area under this line. The line is, let's see, intersects the y-axis at 1, and then it has a slope of 4, which is very steep, but I didn't leave enough room to draw it, so I'm not going to draw it that steep. And then, so basically it's this area here. And the height here is going to be, I'm going to put 1 in for x there. It's going to be 1 plus 4. It's going to be 5, so the height is 5. And then the height here, we're going to put 3 in there. It's going to be 1 plus 12, which is 13. So basically this is like a trapezoid shape. So you can see the integral limits here, 1 and 3. That means that it starts on the left at 1 and it goes to 3 on the right. So the width of this trapezoid is 2, right? The height here on the left is 5, and the height here on the right is 13. Now, if you were to write a rectangle formula for something that has this area, it would be 2 wide. And then if you remember the investigation we did for arithmetic sequence and series, if you have something that is 5 tall on the left and 13 tall on the right, you can take this section triangle and then you could like rotate it around and make it fit right there. And then you would have a rectangle, and it's easier to find the area for a rectangle. So instead of being 5 tall on the left and 13 tall on the right, we're making it into a rectangle, which is exactly halfway between 5 and 13, which would be 9 tall. So the area would be 2 times 9, which would be equal to 18. Okay, for that one. And then for this one, for C, we're gonna we did a similar problem already, where we drew a circle, because this is a circle that is radius 2. And we're finding this area here. Okay. Oh, wait a second. We're doing it from -2 to 2 this time. It's not like what we did before. So it's actually a half a circle. So it's half a circle with radius 2. So a full circle with radius 2 would be pi r squared, which would be pi times 2 squared, which is equal to 4 pi. And in the case that we're doing half a circle, it would be half of 4 pi, which would be 2 pi. Okay? So for C, the answer would be 2 pi, or 6.28. Alright. Moving on to section B, anti-differentiation. The process of finding f of x from f dash of x is called anti-differentiation. So instead of starting with f and finding the derivative f dash, what we're going to do is we're going to start with f dash and we're going to find the original function f of x. And that's called anti-differentiation, which is the reverse of differentiation. The notation blank, actually it's capital F of x, is used to represent the antiderivative of small f of x. Okay, so the function we're always starting with is f of x, and then when we find the antiderivative of it, then we say it's capital F of x. So capital, be careful for those of you who write capitals and small letters in math as if they were the same thing. They hardly ever are. So be careful. Write small f when you mean function, original function. Write big F when you mean antiderivative. Find the derivatives of x squared plus 3, x squared minus 4. Well, the derivative of x squared is 2x. The derivative of x squared plus 3 is 2x also. The 3 goes to 0, right? The derivative of x squared minus 4 is 2x also. So what did you notice? All have derivative 2x. Even though all the functions are different, they all have the derivative 2x. So the antiderivative is one function which has the derivative f of x, but there are an infinite number of functions which have the same derivative. The variations are represented by adding the constant c to the antiderivative. If you notice, like, the difference between this function, this function, this function is always just what constant are you adding? Are you adding a 0? Are you adding a 3? Are you adding a negative 4? So, but if you vary that constant, you can have an infinite number of possibilities. And so we represent that constant, which can be any number, as c. Number 1. Find the antiderivative of, and I want you to just do the odds. So we're going to do this one, this one, this one, and this one. From your answers in A, predict a general rule for the antiderivative of x to the n for n is not equal to negative 1. Okay. So the antiderivative of x, let's see, I think it would be something like x squared. Okay. The derivative of x squared is 2x. Oops, I want x. So instead of having x squared and 2x, I think I'm going to have 1/2 x squared. And the derivative of 1/2 x squared would be exactly x, right? Because it would be 2x divided by 2. Good. Okay. So the antiderivative of x would be 1/2 x squared. Now let's do x to the 5th. So to get x to the 5th, I think it would be like x to the 6th. The derivative of x to the 6th is 6x to the 5th. That's not exactly what we want. We want x to the 5th with no coefficient. So what if we started out with 1/6 x to the 6th? Then the 6's would cancel out and we'd get exactly x to the 5th. So there we go. What about x to the negative 4th? To get x to the negative 4th, I think that we should start with something like x to the negative 3rd. With x to the negative 3rd, the derivative would be negative 3x to the negative 4th. Now we didn't want the coefficient negative 3 in front, so we could divide that out. We could do negative 1/3 x to the negative 1/3. Let's try taking the derivative of that. So that would, the negative 3 would come down and cancel out, so then we would have x to the negative 4th all by itself. Yeah, that's what we want. Okay, and last of all, we have x to the negative 1/2. To get x to the negative 1/2, we would probably start with x to the 1/2, take the derivative, and we end up with 1/2 x to the negative 1/2. That's almost right, except for we have that 1/2 in front that we don't want. So we could multiply, we could start with 2x to the 1/2, and then when we take the derivative and the 1/2 comes down, it cancels out. So then we just end up with x to the negative 1/2, which is what we wanted. Okay, so from these answers, can we think of a general rule for x to the n? Okay, so like for example, for this one, we started out with x, and we took the antiderivative, and we got 1/2 x squared. For this one, we started with x to the 5th, we took the antiderivative, we got 1/6 x squared. For this one, we started out with x to the negative 4th, we took the antiderivative, we ended up with negative 1/3 x to the negative 3. And the last one, we started out with x to the negative 1/2, and then we ended up with 2x to the 1/2. So it looks like we're always increasing, like if we start out with x to the n, then it looks like we're always increasing the power by 1, right? X to the n plus 1. And the other thing we're doing is we are putting n plus 1 in the denominator, I think, like that. Okay, so that's our general rule based on the values that we got here. Okay. Number 2, find the antiderivative of, and here again we're just going to do the odds, so we'll do these 3. Find the antiderivative of these. Let's see, for 1, we'll have the antiderivative of e to the 2x. Let's see, it would be something like e to the 2x itself, because the derivative of e to the x is e to the x, but we need to consider the chain rule. So what do we get here? The derivative is going to end up being 2e to the 2x, but we don't want 2e to the 2x, we just want regular e to the 2x. So what if we started with 1/2 e to the 2x? Then that would exactly cancel and give us a derivative of e to the 2x. So yeah, so this is, I think, our antiderivative for 1. For 3, we start out with e to the, or we want to get e to the 1/2 x. So what if we just took the derivative of e to the 1/2 x itself? We end up with that, which is not exactly what we want. We didn't want the half, so we'll multiply by 2, and now we'll get exactly e to the 1/2 x. Okay, so the antiderivative is that. And last of all, we have e to the pi x. To get derivative of e to the pi x, we could just start with e to the pi x, see what we get. We end up with pi e to the pi x. So if we started out with 1 over pi e to the pi x, that would be perfect. It would end up with e to the pi x with no coefficient, which is what we wanted. Okay, so it looks like here, if we want a general rule of e to the kx, what would be the integral or antiderivative of that? We would want to have exactly the same thing, e to the kx, but we do want to divide by k itself. Okay, so I think that our general rule would be this. Number 3. Find the antiderivative of 6x squared plus 4x by first differentiating x cubed plus x squared. Okay, so I don't know what the antiderivative of this is yet, but it says, oh, here's a clue. Take the derivative of that. So the derivative of that would be 3x squared plus 2x, right? Let's see how that helps us. Well, look at that. That's pretty close to that. It's not quite. Looks like they're different by a factor of 2, right? So instead of taking the derivative of this function, I'm going to double it and see what I get. So I'm going to double this function, and then I'm going to take the derivative, and then I'll end up with 6x squared plus 4x. And then I got the exact same thing. So now I know that the antiderivative is going to be this function which I just invented there. Okay? Alright, and then it says find the derivative, antiderivative of the square root of x by differentiating x square root of x first. So x square root of x is actually equal to x 3/2. So if I take the derivative of x to the 3/2, I would get 3/2 x to the 1/2. And now I say, oh, well, x to the 1/2, that is exactly what we want. But I have a coefficient of 3/2 in front, which I didn't want. Now, what if I started with the reciprocal of that, the inverse of 3/2, 2/3 x to the 3/2, and then I took the derivative, then I'll have 3/2 times 2/3, which is just 1, and I'll be left exactly with x to the 1/2. So now I can see that the antiderivative of square root of x is this. It's 2/3 x to the 3/2. And that's the end for this page.